Hi. In the previous video, we saw how to prove that two sets are equal using subset argument. So in this video, we are going to see how to prove that two sets are equal using identities. So we are given this expression, we are given this set. We are trying to prove that these two sets are equal. So sometimes it can be tricky to manipulate this kind of expression. But what I usually do is I prefer to transform it to something more familiar. So I transform it to this expression. So what we are going to do, instead of proving the first expression, we are going to try to prove the second expression. So we prove basically this one. Now, so we have this is again, this is what we need to prove. You need to prove that, I think I missed something here. You need to prove this expression. So what we are going to do is basically we are going to try to go from this one. You pick whatever you feel that is easier to manipulate, and then you try to get to the other expression. So we consider this expression, which is this. So the goal is trying to play with this expression in order to get this one. So first, what you have to notice is if you have the union of two sets, A union B complement is A complement intersection B complement, and if you have A intersection B complement is A complement union B complement. So these are very useful if you have A minus B. So again, if you have the complement of a set twice is the same set, this is again A. So I'm going to use this small trick in this proof basically. So what we do is since we consider this expression, which is what we have here, this expression, what you do is you can transform. You see that this expression, I transform it basically to this. So using this rule basically, which is what I have here, I transform it to this expression. So from this we can get this expression, the second expression. So we are here now. Because I have the complement of the set twice, so I can apply whatever I have here. This is the definition of a complement. Then from definition of complement we get up to this level. Now we have this expression up to this. So this is basically the same thing as this, but we made some transformation. Now I'm going to apply the distributive law. The reason why you can see that there's different color here, I'm trying to emphasize on something. So if we think of this expression as one big block, so basically what we did, we distribute it with this and then also with this expression. And what I did, that's why I put this with a different color. We have this different color so you can easily see the different what is what. So this is the intersection, is right here, and again inside we have the union. So basically I distribute with the intersection, so it's A intersection C intersection B, so it gives us this part. So the first distribution, which is this, I distribute with this expression, it gives us this part. Now we apply the second distribution and we keep this union here, which is this union. Then I distribute the second expression, so they distribute the second block with the C, so we get what we have here. Again, you can see that this same intersection element is right here. So this is the same intersection, which is this what we have here. So that's how the distributive law here. So we went from this expression to this using the distributive law. Now what you can see from here is because if you have A intersection C complement intersection C, because they are both intersection, you can just put it this way. This is the same as A intersection C complement intersection C. So again, we can distribute the parentheses that way. And when you distribute that, you can see that you are going to have a C intersection C complement. So based on what we have in your lecture note, this is going to be the empty set. So that's why we get this empty set here. So basically this expression is the same as this, and from here we got the empty set. That's what we have here. Now, and then you have, then this expression is still the same, so we just basically copy it here. The union is whatever you have here, this union, which is what we have here. You just copy it there. So it's the same union that we have here. Now because this gave us the empty set, we are going to have a intersection the empty set. And by definition again, if you have every set intersect the empty set, is going to be the empty set. So this again, all this block become the empty set. And you have this property in your lecture note. You can feel free to take a look at that. So this gives you the empty set. Then because you have this block of set union the empty set, is just going to give you basically this block of set, which is nothing else but this set that we was trying to prove. So that's what how to use a set property to basically construct a proof. So basically we went from this expression to this, and which is what we had to prove. Just to recall on the key concept that we use here. So here are some of the key concepts that we use here. We use the A minus A, which is the same as A intersection A complement. This gives the empty set. And also we use the fact that if you have A intersection the empty set, this is going to be the empty set. These are empty set property. We also use the fact that if you have the A union the empty set, is going to be the set A. And you can see that we use this property basically here, because we have this set union, we have this set union the empty set, it gives us the exact same set. So we use this final property at the end of our proof basically. And we also use the fact that if you have A union B complement, is A intersection B complement, this way. And we have A union intersection B complement is A complement union B complement, and A complement is A. And you have to understand that this set A, it could be a block of set, it's a set of set. So A can be something like A union, let's say D union C union E. So you can think of this as one single block, like A. So it's not only one single element, it can be a block of elements, it can be a set of set basically. So that's what I have for the proof using properties. So again, you can stop the video anytime, try to look at that, how it works and why we use what, and basically you're going to use property from your lecture note. And thank you. Hopefully this is going to help you on your homework. And just to give you a hint on whatever you have family of set, I saw that somewhere that you have a set of basically a family of set that you are trying to manage. So you have on one of the state, if you have some stuffed statement like this, K is in a certain set K, AK. You can think of this as basically it's like you are doing something like A1 union A2 union A3 union A4 union A5 union AK. So this is the similar idea, is kind of something like this. So the way to think of this is you just think of this as a big set. So if you have two sets, let's say I have A union B union C complement is going to be A union B complement, and then intersection C complement first. Then if you apply the complement on this, it's going to be, so basically I keep the first part, then apply the complement on the second part. So this complement is there. Then if you apply the complement on this, you're going to have A complement intersection B complement, then you get this complement. So basically when you apply the complement on one set of set, it's going to be A1 complement intersection A2 complement intersection A3 complement intersection A4 complement intersection A5 complement intersection, and so on. So what you have to understand is that on that is basically this set is the same as this, but in order to show that these two sets are equal, like what you have on the homework, you are asked to show that the k in a certain bk of a k equal to the intersection of k a k complement. Now in order to show this, again you must pick one element in this set. You must say let x in, because you are going to show that they are subset of each other. Let x in the union of k a k. So if x is in this, what does that mean? So if x in this set, this imply what? That means x is not in the so I'm not going to give you more extension on this, because if I give you more detail, you can just use whatever I said here to solve your homework, but you have to figure out by yourself. So I just gave you some hints on how to understand this kind of set and how to manipulate it. So hopefully this is going to help you on your homework, and if you have additional questions, feel free to stop by the office hour so we can help you better. Thank you.